All right, number 9, you want to build a greenhouse from at most 500 square feet of material in the shape of a half cylinder. So I've drawn kind of what that would look like up here. The surface area of the greenhouse is given by a formula S equals pi RH plus pi r squared, where r is the radius, so that's going to be the height of our greenhouse, and h is the length of the greenhouse. Write an expression for h in terms of r. Then find all the possible values of r. All right, so the first part of this is we need to write an expression for h. So we need to solve for h, given that we've got at most 500 square feet of material to work with. So if we've got at most 500 square feet of material, the surface area of this is at most 500 square feet. So in other words, the surface area, which is given by this equation, so we have pi RH plus pi r squared, that's equal to the surface area. That has to be less than or equal to 500. So we have at most 500 square feet of material to work with. So now let's solve for h, and that'll give us an expression for h in terms of r. So we subtract pi r squared from both sides. So we're left with pi RH is less than or equal to 500 minus pi r squared. All right, now let's divide both sides by pi r to get h by itself. And we're left with h is less than or equal to 500 minus pi r squared divided by pi r. All right, so that's our expression for h in terms of r. The second part of this is to figure out all the possible values for r. So I want to take a step back and just think about what this actually means. So we've got 500 square feet of material to work with. There's a few different ways that we could configure this. We could have a really small r, which would be a short little greenhouse, and we could make it really, really long, lengthwise. Or we could shorten it up lengthwise, but make it really tall. So there's a lot of different ways to put this together, and we want to figure out all the R values that we could have. In other words, what's the range for this R, which will be the domain of our function? How tall can it be? How short can it be? All right, so to figure that out, let's first consider what limit do we have on h? Well, we know that h can't be negative, right? We can't have a negative length for our greenhouse. So let's set this equal to 0. Let's say that our height, 500 minus pi r squared divided by pi r, that has got to be greater than 0. Because our height obviously can't be 0, or otherwise we don't have a greenhouse, and it can't be less than 0 because we don't know how to measure something in terms of negative numbers. So let's think about this now. Our height has got to be less than or greater than 0. If we were to graph this, there's a couple of points that we would be really interested in. One would be the vertical asymptote. To find the vertical asymptote, that's going to be, we're going to set this denominator equal to 0. So if pi r is equal to 0, then r has got to be equal to 0. That's where our asymptote is going to be. If we graph this, we'd have an asymptote right here at 0. And then the x-intercept for this is going to be where the numerator is equal to 0. So 500 minus pi r squared is equal to 0. Then let's subtract or add pi r squared to both sides. So we get pi r squared is equal to 500 divided by pi. So we get r squared is equal to 500 divided by pi. Take the square root of both sides. R is equal to the square root plus or minus the square root of 500 divided by pi. All right. Which, if we plug that into the calculator, we get that that's about 12.6. Plus or minus 12.6. But notice that we don't care about the minus. That would mean that our r is negative. The radius is negative. That doesn't make any sense. But the 12.6 would be out here. And if we graph this, we'd get a function that looks kind of like this. And we care about just this portion, the part that is greater than 0. So all of the different r values that is going to give us a height that's greater than 0 are going to be r values between 0 and 12.6. So the maximum height of this is going to be 12.6. The minimum height is going to be something bigger than 0. And so, so we're going to write the solution to this as open parentheses 0, 12.6. So this is interval notation, meaning that all the possible r values are between 0 and 12.6.